Generative AI often creates a technical dead end in professional production. You end up with a flattened image or video that shatters into uneditable pixels the moment you need to modify its underlying structure. Pipeline engineers and technical directors cannot work with flat exports. To actually iterate on an asset, they need to manipulate the source data, node graphs, timelines, and modifier stacks. Anthropic's April 2026 Claude for Creative Work update addresses this by moving the model's role away from producing final assets toward interacting with the software building them. Anthropic frames this as an embedded computational assistant. The system is designed to support the creative process by handling the technical execution that often limits the scale of a project. Scaling a pipeline requires an AI reading and writing directly into a host software's native architecture. The mechanism enabling the specific integration is a system Anthropic calls connectors. These connectors are built on the Model Context Protocol, or MCP. MCP grants Claude direct read and write access to the backend APIs of complex industry software. An initial coalition of partners, including Blender, Autodesk, Adobe, Ableton, and Splice, are already using this protocol to link Claude to creative tools. Moving the model from a standalone browser chatbot to an API-integrated agent changes the workflow parameters, placing the AI's reasoning inside the creative environment. To function as an embedded assistant, the language model must first ground its reasoning in the specific software's documentation. For example, the Ableton connector ensures Claude's responses are based strictly on official documentation for live and push. When a creative user makes a request in natural language, it initiates a precise data flow through the system. The natural language request routes into a Claude Context Logic Hub. Claude references product documentation to translate that request into a Python script. That script passes across the MCP connector bridge, executing within the host application's API to trigger a state update. This results in a native update inside the project file, rather than an external asset being pasted in. This architecture is what enables a language model to function as a real-time pipeline engineer. Claude Code handles this engineering by generating custom scripts and systems for the host software. Technical directors can use this to bypass complex manual interfaces when executing procedural tasks. You can instruct Claude to build a custom shader script from scratch. It can script procedural animations on the fly, entirely removing the tedious need for manual keyframing across complex overlapping timeline sequences. In Autodesk Fusion, users can create and modify parametric 3D models through conversation, defining constraints and dimensions naturally. Every script produced is fully documented and reusable, allowing the user to modify the code further as needed. The Blender Python API integration demonstrates the full scope of this extensibility. Using the Blender MCP connector, Claude can add entirely new, user-requested tools directly into the Blender interface. Claude acts as an on-demand developer, expanding the host application's native capabilities based on the specific requirements of a project. Beyond code generation, these connectors target the repetitive manual work that consumes production time. Claude can handle multi-step tasks like setting up complex project scaffolding or applying procedural changes across a scene. Affinity automates batch image adjustments, rapidly renames complex layer hierarchies, and coordinates bulk file exports. 3D artists use the Blender connector to analyze and debug entire scenes, or batch apply changes to multiple objects simultaneously. This deep integration capability also directly addresses the massive friction and difficulty of constant manual handoffs between entirely incompatible software applications. Raw data moves from a SketchUp node into a central Claude translation node. Claude restructures the data to keep assets in sync, directly outputting to a Blender scene node. The pipeline extends further, flowing real-time data into live performance software like Resolve Wire. Seamlessly restructuring data in this way removes the friction of format incompatibility, creating a more unified production environment. Evaluating the wider industry implications of this strategy requires looking at the architecture of the ecosystem itself. For high-level pipeline engineers, open-source interoperability is critical for building resilient workflows. Anthropic built the Blender connector on MCP, making the integration accessible to other language models in addition to Claude. To support this infrastructure, Anthropic has joined the Blender Development Fund as a patron, contributing to the continued development of the Blender Python API. This macro diagram illustrates the vision.
Claude acting as a central hub routing code and data between 3D design, engineering, live performance, and audio production. The industry goal is an interconnected software ecosystem orchestrated by context-aware AI. This orchestration model has moved beyond internal testing and into the classrooms of major design institutions. Top art and design programs are integrating these connectors to support curricula involving creative computation. In the US, this includes the Art and Computation program at the Rhode Island School of Design and the Fundamentals of AI for Creatives at Ringling College of Art and Design. Internationally, the framework is being used in the Computational Arts program at Goldsmiths, University of London. Students and faculty are using these tools to provide direct feedback, helping to define what professional practitioners require from these integrations. By embedding these tools into these curricula, these programs are establishing API-integrated computation as a standard skill for the next generation of production professionals.